For centuries, the fastest way to move goods between East Asia and the Middle East was by sea. Containers leaving Chinese factories would travel thousands of kilometers through crowded shipping lanes, past the Strait of Malacca, cross the Indian Ocean, and eventually reach ports throughout the Persian Gulf. The system worked, but it also created a major vulnerability. A single disruption along those maritime routes could delay shipments, increase transportation costs, and affect supply chains stretching across multiple continents. Today, China is attempting to create an alternative, not with another port, not with another highway, but with one of the most ambitious railway corridors ever assembled across Eurasia. Stretching roughly 10,400 kilometers from western China toward Iran through the deserts, mountains, and steppes of Central Asia, this corridor is designed to move cargo across some of the most difficult terrain on Earth. Supporters see it as a revolutionary trade route capable of reducing shipping times and strengthening.
On a map, the route appears straightforward. In reality, it connects an enormous chain of existing and newly upgraded railway systems stretching from western China through Kazakhstan, Uzbekistan, Turkmenistan, and eventually into Iran. Together, these rail networks create a continuous overland corridor linking East Asia with the Middle East. For China, the appeal is obvious. Nearly anything manufactured in eastern China eventually needs access to international markets. Traditionally, that movement depends heavily on maritime transportation. Ships remain efficient and cost-effective, but they are also slow. A container traveling by sea can spend weeks crossing multiple oceans before reaching its destination. Rail transport offers a different balance. Although generally more expensive than ocean freight, it can dramatically reduce transit times. For high-value goods, electronics, machinery, automotive components, and industrial equipment, those time savings can be significant. But economics is only part of the story. The corridor also supports China's broader effort to diversify transportation routes. Instead of relying on a limited number of strategic maritime choke points, cargo can move through multiple overland pathways across Eurasia. This flexibility becomes increasingly important as global supply chains grow more complex. For countries along the route, the railway also represents economic opportunity. New logistics centers, freight terminals, industrial zones, and customs facilities create additional commercial activity that previously bypassed many inland regions. Cities that once sat far from major shipping routes suddenly become connected to international trade networks. What emerges is more than a railway. It becomes a transportation spine stretching across an entire continent.
One of the biggest misconceptions about the corridor is that engineers simply laid tracks across empty land. The reality is far more complicated. Large portions of the route pass through environments that have challenged transportation networks for centuries. Some sections cross vast deserts where temperatures can swing dramatically between day and night. Others pass through mountain regions where steep slopes, unstable geology, and extreme weather create constant engineering obstacles. In desert regions, one of the greatest threats is shifting sand. Unlike fixed terrain, sand dunes are constantly moving under the influence of wind. Left unchecked, they can gradually bury railway infrastructure and disrupt operations. To combat this problem, engineers deploy a combination of protective barriers, vegetation programs, stabilization techniques, and continuous maintenance systems. In some locations, specially designed windbreak structures help reduce the movement of sand toward railway corridors. Elsewhere, vegetation is planted to stabilize surface materials and reduce erosion. Mountain sections introduce an entirely different set of challenges. Rather than moving around difficult terrain, engineers often move directly through it. Long tunnels reduce steep gradients and create more efficient routes through mountain ranges. Massive bridges span valleys and rivers that would otherwise require lengthy detours. Every tunnel excavation introduces additional complexity. Geological conditions can change unexpectedly. Rock stability must be constantly monitored. Water infiltration can threaten both construction schedules and long-term operations. In many cases, advanced surveying technology is used to map underground conditions before excavation even begins. Meanwhile, modern freight corridors require more than tracks. Signal systems, power infrastructure, maintenance facilities, communications networks, logistics terminals, and border processing centers all need to operate as a unified system.
Most infrastructure projects attract regional interest. This railway attracts global attention. The reason is simple. Trade routes shape economic power. Throughout history, transportation corridors have influenced the rise of cities, industries, and entire civilizations. When transportation patterns change, economic geography often changes with them. Supporters argue the corridor strengthens connectivity across Eurasia. Reduced transportation times can improve supply chain efficiency and create new opportunities for trade between participating countries. Manufacturers gain additional shipping options. Logistics companies gain alternative routes. Landlocked regions gain improved access to international markets. But critics view the project through a geopolitical lens. They argue that large-scale infrastructure can influence regional relationships and increase economic dependence among participating nations. Because the railway links multiple strategic regions, its significance extends beyond freight transportation. The corridor forms part of a broader network associated with China's Belt and Road Initiative, one of the largest infrastructure development programs in modern history. As that network expands, questions naturally emerge. Could new overland corridors reduce the importance of traditional maritime routes? Could freight movement gradually shift toward alternative transportation systems? Could economic influence follow infrastructure investment? These debates help explain why policymakers, economists, and security analysts across the world continue monitoring the project closely. For the United States and many Western observers, the railway is viewed not simply as transportation infrastructure. It is viewed as part of a larger strategic transformation taking place across Eurasia. Whether that transformation ultimately succeeds remains an open question, but the scale of the ambition is impossible to ignore.
From the deserts of Central Asia to the rail networks of Iran, this 10,400-kilometer corridor represents one of the most ambitious transportation projects of the 21st century. It is a story about engineering, a story about logistics, and a story about how infrastructure can reshape the movement of goods across continents. Engineers have spent years overcoming deserts, mountains, extreme climates, and enormous logistical challenges to create a railway system stretching across vast portions of Eurasia. Supporters see faster trade, stronger connectivity, and new economic opportunities. Critics see broader geopolitical consequences that could influence regional power dynamics for decades. What is certain is that this project demonstrates how railways remain powerful tools even in an age dominated by ships, aircraft, and digital commerce. Sometimes the future of global trade is not built on the ocean. Sometimes it is built one rail at a time across the desert. If you enjoy engineering megaprojects, infrastructure documentaries, and the stories behind the world's most ambitious construction projects, subscribe to Mega Build HQ and join us for the next journey into the extraordinary world of modern engineering.